Engineering history is a fascinating journey through human innovation and problem-solving. It spans thousands of years, beginning with the earliest tools and structures created by ancient civilizations and evolving into the complex technological systems we rely on today. The story of engineering starts with early human societies who developed fundamental tools and techniques to manipulate their environment. This includes the invention of simple machines like levers, pulleys, and inclined planes, which laid the groundwork for more advanced engineering principles. In ancient civilizations, engineering achievements were significant. The Egyptians, for example, constructed monumental structures such as the pyramids, employing advanced understanding of geometry and materials. The Romans engineered impressive infrastructures like aqueducts, roads, and bridges, showcasing their expertise in construction and hydraulics. The Middle Ages saw the rise of various engineering advancements, including advancements in military technology and fortifications, as well as innovations in mechanical devices like windmills and water mills. The Renaissance period brought a renewed focus on scientific inquiry and experimentation, influencing engineering with figures like Leonardo da Vinci, who sketched numerous inventive machines. The Industrial Revolution marked a transformative period in engineering history. It introduced new materials, such as steel, and advancements in manufacturing processes, such as the steam engine. This era saw the rise of large-scale production and the development of railways, factories, and other critical infrastructure. In the 20th and 21st centuries, engineering has continued to evolve rapidly, driven by advances in computing, electronics, and materials science. The digital age has brought about innovations such as the internet, robotics, and artificial intelligence, expanding the scope of engineering applications and transforming daily life. Engineering history reflects humanity's quest to solve problems and improve the quality of life through technological advancements. It's a testament to creativity, ingenuity, and the relentless pursuit of progress. The 17th century was a period of significant innovation in engineering, laying important groundwork for future advancements. Here are some key projects and products from that era. 1. The development of the steam engine. Thomas Savery's engine, in 1698, is often considered one of the earliest forms of the steam engine. Savery's engine was designed for pumping water out of mines. It was a simple and rudimentary device that used steam pressure to create a vacuum and draw water. Thomas Newcomen's engine, in 1712, though a bit outside the 17th century but closely related, was an improvement on Savery's design. Newcomen's engine was more efficient for pumping water and became widely used in mines and other industries. 2. Hydraulic engineering and water management, canal systems. The 17th century saw the construction of numerous canal systems in Europe, which were crucial for transportation and trade. The most notable is the Canal du Midi in France, completed in 1681 under the direction of Pierre-Paul Riquet. This canal linked the Atlantic Ocean to the Mediterranean Sea, revolutionizing trade and transport in the region. Hydraulic mills. Advances in hydraulic engineering improved the design and efficiency of water mills used for grinding grain and other purposes. Innovations included more efficient water wheels and mill races. 3. Architectural and structural innovations. The Royal Greenwich Observatory, founded in 1675 by King Charles II in England, was designed to advance the study of astronomy and navigation. The precision instruments and architectural design were ahead of their time and contributed significantly to both fields. St. Paul's Cathedral, completed in 1710 and designed by Sir Christopher Wren, is an architectural marvel in London that showcases the engineering advances of the period, including innovations in dome construction and structural stability. 4. Military engineering and fortifications. Star forts. The 17th century saw the widespread use of star forts, a type of fortification designed to withstand cannon fire in siege warfare. They featured angular bastions that provided better defensive capabilities against artillery. 5. Mechanical devices and innovations. The clockwork mechanisms. Advances in clockmaking included more precise and durable mechanical components. The 17th century saw improvements in escapements and the development of pendulum clocks, which greatly enhanced accuracy. 6. Scientific instruments, barometers and thermometers. The development and refinement of these instruments allowed for better measurement of atmospheric pressure and temperature. Notable figures such as Evangelista Torricelli and Daniel Gabriel Fahrenheit contributed to these innovations. These innovations reflect a period of significant growth and experimentation in engineering and technology, setting the stage for the dramatic developments of the 18th and 19th centuries. The 18th century was a period of remarkable engineering progress, driven by the Enlightenment's emphasis on scientific inquiry and practical problem solving. This era saw the development of new technologies, improved infrastructure, and innovative engineering solutions that laid the foundation for the Industrial Revolution. Here are some key highlights. Advancements in mechanical engineering. Improved steam engines. James Watt's steam engine in 1765. James Watt made significant improvements to the steam engine, originally developed by Thomas Newcomen. Watt's enhancements, including the separate condenser and the introduction of rotary motion, greatly increased the engine's efficiency and power, driving the Industrial Revolution. Mechanical looms. Edmund Cartwright's power loom in 1785. Cartwright's invention mechanized the weaving process, significantly improving the efficiency of textile production. This innovation played a crucial role in the growth of the textile industry during the Industrial Revolution. Civil and structural engineering. Bridges and roads. The Iron Bridge in 1779. Designed by Abraham Darby III, the Iron Bridge in Shropshire, England, was the first major bridge constructed entirely of cast iron. It demonstrated the potential of iron as a building material and influenced future bridge construction. John Smeaton's Eddystone Lighthouse in 1759. Smeaton designed a new lighthouse on the Eddystone Rocks using hydraulic lime, which improved durability and stability. His work set new standards for lighthouse construction. Canal construction. The Bridgewater Canal in 1761. Designed by James Brindley, this canal connected the coal mines in Worsley to Manchester. It was one of the first major canals in England and greatly facilitated the transportation of goods, spurring industrial growth. Hydraulic engineering. The development of hydraulic machines, the hydraulic press, in 1795. Joseph Bramah invented the hydraulic press, which used hydraulic force to compress materials. This device was crucial for manufacturing and demonstrated the practical applications of hydraulic principles. Architectural innovations. Neoclassical architecture. The 18th century saw the rise of neoclassical architecture, characterized by its symmetry, proportion, and use of classical elements. Engineers and architects like Robert Adam and James Stewart incorporated new materials and techniques into their designs, influencing the construction of public buildings and monuments. Scientific instruments and innovations. Developments in astronomy. William Herschel's telescope in 1781. Herschel improved the design of telescopes, allowing for better observation of celestial objects. His work contributed to the discovery of Uranus and advanced the field of astronomy. Electrical engineering. Benjamin Franklin's experiments with electricity. Franklin's experiments with lightning and static electricity, including the famous kite experiment in 1752, advanced the understanding of electrical phenomena and led to the development of the lightning rod. Military engineering. Fortification design. Vauban's fortifications. Although Vauban's work began in the 17th century, his principles continued to influence military engineering in the 18th century. His designs for star-shaped forts and fortifications were used extensively in European military strategy. These engineering achievements of the 18th century reflect a period of innovation and transformation, setting the stage for the rapid technological advancements of the 19th century. The 19th and 20th centuries were periods of extraordinary innovation and transformation in engineering, characterized by rapid technological advancements and revolutionary projects that reshaped industries, infrastructure, and daily life. Here's an overview of key engineering achievements from these two centuries. 19th century mechanical and industrial engineering, the development of the modern steam engine. James Watt's improvements, from the late 18th to early 19th century, laid the groundwork for industrial growth. In the 19th century, steam engines were further developed and widely used in locomotives, ships, and factories. George Stephenson's locomotives, known as the father of railways, Stephenson built the first successful steam locomotive, Locomotion No. 1 in 1825, and the famous rocket in 1829, revolutionizing transportation and industry. The emergence of the factory system, Eli Whitney's cotton gin, though invented at the end of the 18th century, had a profound impact in the 19th century by mechanizing the process of separating cotton fibers from seeds, boosting productivity in the textile industry. Civil and structural engineering, iconic bridges. The Brooklyn Bridge, completed in 1883, was designed by John A. Roebling and completed by his son, Washington Roebling. This suspension bridge in New York City was the first to use steel cables and was an engineering marvel of its time. The Forth Bridge, completed in 1890, was a cantilever bridge over the Firth of Forth in Scotland. It was one of the first major structures to use steel extensively and remains a symbol of 19th century engineering prowess. Skyscrapers and urban development. The Home Insurance Building, located in Chicago and completed in 1885, is considered the first skyscraper due to its use of a steel frame, allowing for greater height and a new architectural era. Hydraulic engineering. The Suez Canal, designed by Ferdinand de Lesseps and opened in 1869, is an artificial waterway that connects the Mediterranean Sea to the Red Sea, significantly shortening maritime trade routes between Europe and Asia. 20th century mechanical and aerospace engineering. The development of jet engines. Frank Whittle in the UK and Hans von Ohain in Germany independently developed the first practical jet engines during World War II. This innovation transformed aviation, leading to the development of faster and more efficient aircraft. Space exploration. NASA's Apollo program in the 1960s culminated in the Apollo 11 mission in 1969, which successfully landed the first humans on the moon. This achievement demonstrated extraordinary advances in aerospace engineering, including spacecraft design, navigation, and telemetry. Civil and structural engineering. The Hoover Dam, completed in 1936, is located on the Colorado River. This massive concrete dam was a monumental achievement in civil engineering, providing hydroelectric power, water storage, and flood control. The Channel Tunnel, often referred to as the Chunnel, was completed in 1994. This underwater rail tunnel connects the UK with mainland Europe, requiring advanced engineering techniques and representing one of the most significant infrastructural projects of the 20th century. Environmental and chemical engineering. Development of sustainable technologies. The 20th century saw significant advancements in water treatment technologies, including the development of modern filtration systems, chlorination, and biological treatment processes to ensure clean water and reduce pollution. The Green Revolution, from the 1940s to the 1960s, saw the development of new agricultural technologies including high-yield crop varieties and advanced irrigation techniques, which significantly increased food production worldwide. Information and computing engineering. The invention of the computer. The ENIAC, completed in 1945, is often considered the first general-purpose electronic digital computer. It was a groundbreaking achievement that laid the foundation for modern computing technology. Integrated circuits. The development of integrated circuits in the 1950s and 1960s revolutionized electronics, leading to the proliferation of personal computers and advanced electronic devices. Summary: the 19th and 20th centuries were marked by transformative engineering advancements that reshaped society and industry. From the steam engines and skyscrapers of the 19th century to the space exploration and digital revolutions of the 20th century. These innovations reflect a period of unprecedented progress and have laid the groundwork for contemporary technological and engineering achievements. Early foundations and development. Early engineering education, military academies and technical schools in the 18th and 19th centuries. The United States Military Academy at West Point, founded in 1802, was established to train military engineers. It emphasized civil engineering, military engineering, and surveying. École Polytechnique in France, established during the French Revolution in 1794, was among the first to offer a broad scientific and engineering curriculum, including mathematics, physics, and engineering sciences. Professional engineering societies. The Institution of Civil Engineers, founded in the UK in 1818, played a significant role in promoting engineering education and standards, supporting the development and recognition of civil engineering as a profession. Establishment of engineering departments. 19th century developments. The Massachusetts Institute of Technology, established in 1861, focused on practical and scientific education. Its School of Engineering, created in the latter part of the 19th century, was among the first to offer dedicated engineering programs and research opportunities. The University of Illinois at Urbana-Champaign, founded in 1867, is known for its early engineering programs and has a long history of engineering education and research. Early 20th century expansion, the University of California, Berkeley, established its College of Engineering in 1900, reflecting the growing importance of engineering education in the United States. Imperial College London, formed in 1907 from the merger of several institutions, became a leading center for engineering education and research. Evolution and modernization, mid-20th century, rise of specialized departments. Engineering departments began to specialize in various fields, such as mechanical, electrical, chemical, and civil engineering, allowing for deeper exploration and development in each area. Growth of research engineering departments increasingly emphasized research, contributing to advancements in technology and practice. Institutions like Stanford University and the California Institute of Technology became renowned for their engineering research. Late 20th century to present, interdisciplinary approaches. Modern engineering departments often embrace interdisciplinary approaches, integrating fields such as bioengineering, environmental engineering, and computer science. Global expansion. Engineering education has expanded globally, with many universities worldwide establishing robust engineering programs and departments, contributing to a global engineering community. Key elements of engineering departments: curriculum, fundamentals. Core subjects typically include mathematics, physics, and engineering sciences. Specializations, advanced courses and specializations in various engineering disciplines such as aerospace, civil, electrical, and mechanical engineering. Research laboratories and facilities. Modern engineering departments often feature state-of-the-art laboratories and research facilities. Innovation and development. Focus on research and development that drives technological innovation and addresses real-world problems. Industry collaboration, partnerships. Collaboration with industry partners provides students with practical experience and helps to align educational programs with industry needs. Internships and co-ops. Opportunities for hands-on experience through internships and cooperative education programs. Conclusion. The establishment and development of engineering departments have been pivotal in advancing engineering education and practice. From early technical schools and military academies to modern research-intensive institutions, these departments have played a crucial role in training engineers, fostering innovation, and addressing global challenges. The evolution of engineering education reflects the increasing complexity and importance of the field, shaping the future of technology and infrastructure. Evolution of engineering departments in the 20th century. Expansion and specialization. Early 20th century specialization engineering departments began to specialize into distinct disciplines such as civil, mechanical, electrical, and chemical engineering. This allowed for more focused research and development. Research emphasis. Institutions like MIT, Stanford, and UC Berkeley began to place a stronger emphasis on research, setting up dedicated research centers and laboratories. Mid to late 20th century growth of new disciplines. New engineering disciplines emerged, including aerospace engineering, nuclear engineering, and biomedical engineering, reflecting technological advancements and societal needs. Interdisciplinary programs. Engineering departments increasingly adopted interdisciplinary approaches, incorporating elements of computer science, materials science, and environmental science into their curricula. Technological and educational advancements. Modernization of facilities. Laboratories and equipment. Universities invested in state-of-the-art laboratories and equipment to support advanced research and practical training. Computing resources. The rise of computers and digital technologies transformed engineering education, with departments incorporating computer-aided design, simulations, and modeling into their programs. Curriculum development. Industry collaboration. Engineering programs began to include industry partnerships, internships, and cooperative education opportunities to provide students with practical experience and align education with industry needs. Professional accreditation bodies, such as ABET in the U.S., were established to ensure the quality and relevance of engineering education. Development of AI courses. Early foundations. The birth of AI. The Dartmouth Conference in 1956 is often considered the birth of AI as a field. This conference brought together pioneers like John McCarthy, Marvin Minsky, and Alan Newell. They proposed the study of artificial intelligence, setting the stage for future research. Early research. Initial AI research focused on problem-solving and symbolic methods. Key early developments included the creation of the Logic Theorist, the first artificial intelligence program, which was designed to mimic human problem-solving skills.